Hello everyone, this is Anugolu Raviteja, currently pursuing third year of B.Tech in Computer Science and Engineering at SRM University AP. I am passionate about data science and machine learning, and in this video I am excited to walk you through my end-to-end ML project titled IncomeIQ. Here the project overview of the IncomeIQ. IncomeIQ is a machine learning based income classification system that predicts whether an individual earns more than $50K or less than or equal to $50K annually. It uses various demographic and personal features like age, education, occupation, working hours, and maternal status, and some of the other relevant features to that. This project covers a complete ML pipeline starting from data preprocessing, feature engineering, and visualization to model building, evaluation, and Power BI dashboards. Here, the workflow of the project. The This project involves some of the key steps like importing libraries, loading and exploring data sets, checking and cleaning invalid values, replacing the missing values with most frequently repeated value, that is mode, feature engineering, data visualization, and model building with feature scaling, model evaluation, and in the final step, Power BI dashboard. Now let me share my screen to move on to the project. Here, as we discussed, here in the first step, we are importing libraries. We import the core libraries needed for the data analysis and visualization, like pandas for loading and manipulating, analyzing data, structured tabular data, NumPy to perform fast mathematical operations and handle numerical arrays, Matplotlib for creating static graphs like bar and line charts, and Seaborn is used for essentially pleasing and statistical visualizations. Plotly.express is used for creating interactive plots like scatter plots and histograms. These libraries are also we called as backbone to the project. Unloading the dataset. In these lines, we are loading the datasets. We load the adult income dataset stored in the Google Drive. What this two lines does is pd.read CSV reads the CSV file and stores the data frame named DF here. By using this line df.head of 10 displays the first 10 rows like here from 0 to 9, giving a quick glance at the data sets structure and contents. Let's understanding of dataset. Before diving into the visuals or machine learning, it's crucial to understand the dataset contains. The typical columns include here age, work class, maternal status, occupation, race, sex, etc. Here df dot shape. Here df dot shape returns rows, that is number of rows. Number of rows, that is here 48,842 rows are there and 15 columns are there. Uh, there are 15 features covering aspects like age, education, work type, income. These substantial datasets providing enough depth for both insightful analysis and accurate machine learning predictions. Here df.datatypes provides the data type of that feature, like here age is int like numerical, work class is object categorical. We can categorize feature based on the data types. Like numerical features, these are continuous or discrete numbers like age, final weight, educational num, categorical gain, hours per week. Those are the numerical features. Some of the categorical features include work class, education, maternal status, are those things. Why this analysis is important? Numerical features may need normalization or scaling before feeding them into the models. Categorical features will need to be encoded. We will use label encoding based on to convert the categorical data into numerical data. Understanding of types of features. helps us avoid errors in pre-processing and modeling. Now let's discuss about this df.isNull.sum function, what it does. Here we can see this returns the number of null values in each attributes. For the attribute of A, there is 0 null values. Here we can see all features returns 0. That means every column shows 0 missing values. No missing values detected. That means we don't have to impute or drop any rows due to null entries, saving us valuable pre-processing effort. Now let's discuss nf dot unique. This one, what this does? This function reveals how many unique values in each column. Like in the age, there are 74 unique values are there, and in work class feature, there are 9 unique values. Like those, all those features return how many unique values in that feature. df dot describe dot t. This function used only on the numerical values like age, final weight, educational num, capital gain, capital loss, hours per week, and all those numerical features. We are doing some mathematical calculations called count, mean, standard deviation, minimum, maximum. Here, respective values are to be displayed. Like for the age, the mean of the age is 38.64, like that. Here, we are gonna discuss about value count function. Here we can see df dot work class dot value count. Here it it returns the items in that feature. Like in the work class, there are items called private, self-employment. This returns the number of privates are there in work class. Like there are 33,906 privates are there in work class, and the null values are 2,799. Like this are written. What we can insight that we drawn from this is most individuals are employed in the private sector, but there are nearly 2.8k unknown entities which are need to be cleaning. Similarly, we are gonna draw insights about that, and we are gonna see how many missing values are there, what is the most frequently repeated value in the each feature. Here we are doing for all those features like occupation, native country. Here we can see in the every feature there are some missing values for maternal status, gender, race. Here we are plotted the graph. Here it consists of on the import Seaborn. Here we can see visual this visualization. This visualization shows how many males and females fall into each income category, that is less than or 50k dollars or greater than 50k dollars. The insights we can draw is on x-axis. We are taking income levels like less than or equal to 50k dollars, greater than 50k dollars. On the bars we are splitting by gender like male and female. Here the blue color one is for male and this light colored brown is for female. What we can draw is most individual earns less than or equal to 50k regardless of the gender. Males males are more likely to earn greater than 50k compared to females. This might reflect gender disparity in income or occupational roles and is crucial for building fair and unbiased models. Here the same process is repeating like value dot count function used to Return the values which are most frequently repeating in that one. Like here we are gonna discuss about how to handle missing values. Like in the previous we have seen the question marks in the each feature. Now let's discuss what we can do to resolve that. Real world data sets often contains missing or ambiguous entities. In the income IQ project, we encountered placeholder values like question marks in some columns, which can negatively impact model accuracy and insights. Here, what we can do is instead of removing rows, we which lead to data loss, we decided to replace the unknown value like question mark with most frequently repeated value mode of that respective column. Here we are replacing the question mark with private for the feature work class, replacing question mark with this one for the feature occupation, for the feature native country replacing question mark with United States, like that. Here we are again uh, checking the if structure of the data set for the 8 items from 0 to 7. Now, feature engineering. Feature engineering is the process of transforming raw data into meaningful features that improve the performance of the machine learning models. For income IQ, we refine education, maternal status, and income attributes to make them cleaner, more interpretable, and model friendly. Here, in this, we are simplifying the education column. The original education column had too many categories, some of which had very few records. To reduce dimensionality and group them meaningfully, we are combining them into similar categories. Here we can see preschool, first to fourth, fifth to sixth, all those are we are converting into single one, that is school. Similarly, we are doing the same thing for the all those remaining features and values. Here, what is the use of this is this makes it easier to analyze trends and reduce the noise during the training. In case of maternal status also we are doing the same thing, and in case of income also we are doing the same thing. Replacing and after doing the replacing and adjusting the values, we are again checking for the data set by using df.head. Here we are getting the data set which consists of all those features and all those values, which provides the overall view of the data set. Here df dot correlation analysis in income IQ to understand which feature are more influential in the predicting income. We analyzed the correlation matrix of all numerical columns. The correlation coefficient ranges from -1 to 1, in which +1 indicates perfect positive correlation, 0 indicates no correlation, -1 indicates perfect negative correlation. Here we are. Here we have seen heat map. Here, what is this heat map provides is shows correlation between all numerical features in our data sets. What are the use of this heat map is helps you to find most impactful numeric feature for your model. And again, we are gonna move to the histogram. In the above, we in the heat map for all those numerical features. For in case of histogram, what it does is plots histogram for each numeric column, like separately for age, capital gain, etc. Useful for checking distribution. Here for age, capital gain, educational hours per week, like that. For each feature, different. for box. What this box plot does is shows box plots for each numeric feature. What are the insights that can be drawn from this box plot is easily detect outliers like medians and interquartile range. Here these are the outliers. In case of above age of 80, we are considering them as outliers. Here in case of capital gain, more than zero or we are considering as outliers. That is here 1 lakh is the outlier. In case of income, 1 is the outlier like that. Let's discuss about the pie chart. Here, here the pie chart we are given different colors for the different features like blue for the higher, orange for the high school, red for the undergraduate, sky blue for the graduate, green for the school, yellow for the doctorate. What are the insights that can be drawn from this pie chart is shows the distribution of education levels weighted by educational number. Now let's see about the bar graph. From this bar graph, what are the insights that we can be drawn is bar graph plot shows number of males versus females in each education category, like in school, high school, higher, undergraduate, like that. By using this, it is great for seeing gender disparity in education levels, like in school. There we can see there will be always be a males, that is males are greater than females at each education level category. Here model building. X contains here what we are doing is X contains all the features except for the income, and Y contains the feature called income. Scale and feature scaling. Here feature scaling you apply two processing. Here we are applying two pre-processing steps like label encoding, that is converting categorical data to numerical data, and the standard scalar which normalize numerical features by subtracting the mean and dividing by the standard deviation, makes them have a mean of 0 and standard deviation of 1. This is important because machine learning models often perform better when all features on the similar scale. Here we are doing the train test split. Here the train test splits the data into training and testing sets. Here 70% of the data is used for the training, and that is X train and Y train, and 30% is used for the testing, X test and Y test. Here random state equal to 40 represents the split is reproducible. Next step in the model building is okay. Here we are doing checking from support vector missions some of the algorithm. Support vector mission is a supervised learning algorithm used for classification and regression tasks. It finds the best hyperplane that separates the classes in feature space. It tries to maximize the margin between the two classes. The support vectors are the data points that lie closest to the decision boundary. They are crucial in defining the position and orientation of the hyperplane. It can handle non-linear classification using kernel functions. What are the advantages of this support vector mission is works well with high dimensional data and effective in case where the number of features greater than number of samples. For here logistic regression, despite the name, logistic regression is used for the classification but not for the regression. It estimates the probability that given input belongs to a particular class using the function called sigmoid. How it works is it computes linear combination of input features and applies the sigmoid function to output between 0 and 1. If the probability is greater than 0.1, it is labeled for the class 1 and otherwise it is labeled for the class 0. We are on the classifier random forest. Random forest is a ensemble learning method that builds a collection of decision trees and matches their outputs to improve accuracy and avoid overfitting. It creates many decision trees on random subsets of the data. Each tree gives a classification result and final output is decided by majority voting. It provides high accuracy. Let's conclude this after conclusion. Now let's see the visual representations of this by using Power BI. Power BI is a dynamic data visualization dashboard built with a Power BI to reveal key demographic and income patterns from a real-world income dataset. In this walkthrough, we will explore multiple visualizations that helps us uncover powerful insights about the people's age, income, gender, education, and work habits. Here in this pie chart, we are gonna discuss about gender distribution pie chart. We begin with the gender distribution in the data. The pie chart shows the proportion of male and female participants. From the chart, we observe a higher number of male entries than female, indicating skew in the data sets. This is calculated using the count of the records grouped by gender, providing a quick overview of representation. Here, the male is shown with deep blue, that is 1,28,000, that is nearly 68.32 percentage, and for the female only 31.68 percentage. We also calculate the sum of the ages across all datasets to get the idea of collective experience in terms of age. Here we are gonna discuss about income level distribution donut chart. Level distribution using donut chart. We compare two groups like greater than 50K dollars income and the individuals which are earning less than or equal to 50K dollars. This visualization highlights that majority of the population earns less than or equal to 50K, reflecting income disparities. Here orange means zero. Here we can see 76.07 percentage of people are having the income less than or equal to 50K dollars, and only in 23.93 percentage of people having the income greater than 50K dollars. Now let's see about the income IQ occupation versus count. Our next visualization is the tree map that displays the count of the individual by occupation. Here each tile represents here each tile represents an occupation such as professional specialty, craft, repair, cleric, other services like that. The size of the title indicates how many individuals fall in that category. The tree map makes it easier to identify the most common professions in the dataset at a glance. Here we have age versus average hours per week. Here we have a blue line graph. Now let's examine the relationship between age and working hours using the line chart. Here the x-axis indicates that age, y-axis indicates the average hours worked per week. From this chart, we notice that Younger and older age groups tend to work significantly higher. Younger and older group Younger and older age group tend to work significantly fewer hours when compared to the middle-aged individuals that are between 30s and 50s work most consistently. This chart provides a great insight into how work commitment varies by age. Here we can see the graph is higher from between 30 to 50, and after that it again decreases like that. And the final graphical representation about gender versus income level bar, bar chart. Lastly, we represent a bar graph comparing gender with total income level. Each bar shows the sum of income levels grouped by gender. This helps observe if there are any gender bias disparities in the income distribution. From these visuals, we might infer if one gender tends to earn more or if the dataset carries any bias. Here we can see for the male, most of those are male, only few are female. Like that, we can visually represent or visually analyze the trends by using the bar graph. This is all about the project name Income IQ. Income IQ is just isn't about a dashboard. It is a an overall story that tells about data. It brings together demographic and income factors into one cohesive view, empowering users to explore population trends, compare income by work types, analyze occupation distributions, understand how age and gender affect worker habits and earnings, like that. This is what about my Income IQ project. If you have any doubts, let's put those doubts in comment section. And this is it.